Alright, so picking up where we left off last time. Uh-oh. I just got rid of it. Alright. Back to it. It says, okay, side combos need to be done. It says, complete the following proofs. So this is what you're doing on the Delta Math today. You're not given any of the parts already filled in. We have to go from scratch. Okay? So, it says, given that KL is congruent to LN, or NL, and that KM is congruent to NM, prove that the two triangles are congruent. Okay, this picture's already labeled for us. I told you they're not always already labeled. This one it was. So what is a given that we can put for our first piece?
KL is congruent to NL.
Okay, KL is congruent to NL. Make sure you know where that is. Okay, Evan and whoever else back there, get quiet. Make sure you know which sides that is. So that was KL and LN. Alright, those are the two sides we've talked about so far. What's another given that we have? What's another given? We use this one. Ooh, it's all blurry.
KM and
Good.
Oh, shoot, I forgot to do it. Man.
Alright. So now we're saying KM is congruent to NM. Okay. That was these two sides. What other information from our picture can we prove?
KL.
Gretchen?
KL equals NL.
Okay, Josh, I didn't call your name. LM is congruent to LM. What's our reason?
Reflexive.
Okie dokie. So LM is congruent to LM because it's in both triangles.
it's like right here.
And our reason is the reflexive property. If it's the exact same side, property of congruence.
I thought it was POE.
You can call it either one.
I thought it was
If we're talking about two things being equal, you can put E. If we're talking about two things being congruent, you can use C. It's just a property of the two things being the same. Okay? So we are now going to put what we were trying to prove, and then our reason, which will be the side that Chloe said. So we were trying to prove that triangle KLM was congruent to triangle LM.
It's still there.
LNM. Okay. I shouldn't have to say shh every single time I stop talking. Just be done talking. Alright, and our reason is what Chloe just said. This was side, triangle congruence. Okay.
How is it side?
Because it's three sides.
We had these two sides were the same, these two sides were the same, and they shared this side, so it's the same, so the side.
So all the sides the same and sets the side.
Yep, because we didn't know anything about any angles for that one. Okay, moving on to number 2. It says we are given that AD is parallel to EC, and that BD is congruent to BC. Alright, let's talk about what that means. We know these two sides are parallel, and that these two sides are the same. We want this stack here to become whatever our triangle congruence theorem is. So we have the one given out in front because parallel doesn't tell us anything about the sides directly. We're going to use that to find something about either an angle or a side.
I know it's one.
Okay. So if we want this stack here to be either our side angle, hypotenuse leg, whatever, which given should we put here?
AD is parallel to EC.
Wrong.
BD is equivalent to BC.
Okay, because it gives us a side, right?
It's not, if you don't know it, don't say
Okay, shh. That's not true. He can try.
No, he can't. He can't try if it's always wrong. No one wants to hear it.
So we want to use the information about a side or an angle in our stack of 3 to become one of our congruence theorems. Which means our other given is the front one. So we're going to put our AD being parallel to EC out front. Okay. From that information, knowing that these two sides are parallel, what information can we get that's going to help us in this picture?
They equal each other.
What equals what?
AD.
What? Angle C and angle D. What about them? Okay. What else do we know? A.
Oh, that's not true.
Think about what we need to get to here.
Oh my goodness.
So we can go with Chloe's first. That's fine. So you said C and B, right? C and B. So angle C is congruent to angle D by what's our reason?
Angle C. Oh, like,
The sides are the
vertical,
same.
vertical angles. No, that's
Sides are the same. Sides are the same.
What type of angles are these? Alternate interior angles. All right, alternate interior angles. You also could have used E and A because those are also alternate interiors cut by the other transversal.
So it's going to be side angle.
I used A and E. I don't know why. It doesn't make a difference. But if you used A and E as your two alternate interiors, you're not wrong. There's not always only one right answer. Okay? All right. So right now we've got a side and an angle. Cool. What else do we know?
We need another side.
Angle B.
Oh yeah, we need another angle.
Angle B.
Because it's anything but ass, and that's the only one left, so it has to
Okay.
be angle, side.
So the angle B.
Angle B. What's B? There's 4 angles created at angle B.
It's a
Vertical.
Is it?
But what angle B? There's 4 different angle Bs. There's this angle B, this one, this one, this one.
And angle B.
Angle ABD.
All of them.
ABD and CBE. All right. So angle ABD, that's the inside of this one, is congruent to angle CBE,
Should be C.
which is this side. By what reason?
Vertical angle.
Vertical angles.
I think that's exactly what Tobias was saying.
Okay. So what were we trying to prove?
That
That ABD is equal or congruent
Triangle ABD
EBD.
was congruent to triangle. Okay. And what's our reason?
Angle, side.
Angle, side. So this is the one Josh was talking about earlier. Could you have written this as side angle since that's the way in which you proved them? You could. That's just not normally how we name it.
Wait, why do you write angle side?
Good job, because we didn't have an angle. Oh, we did for ours, didn't we?
Yes, we do.
So we could have. You could have used angle, side, angle here.
That's what I said.
I was thinking angle, side because I used A and E when I did mine. So you could get there either way, I guess.
Well, does it really matter that much? It's the exact same thing.
Well, in our picture, though, that's what we labeled was an angle, side, and angle.
Does it matter?
I said angle, side because I used A and E when I did mine.
Wait, we have to label it too?
Yeah.
You said angle side is the same as angle side angle.
That's a side. That's a side angle
Is that what
side.
you're saying?
This is angle, side, or angle, side, angle.
So it could be
That there's a
It
side.
should be angle, side, angle, but I used the other one, so that's why I'm missing it.
You told us that before yours
Well, why'd you write angle
it's
side?
actually just stuck with this whole
Actually,
Why'd you write angle side?
Because when I proved mine, when I did it on my own, I used this angle instead of that one. So I really used this method in my head, but that's the one you guys used. What?
Are you sure?
Huh? It should be, yeah. All right.
It's not ASA.
All right. So number 3, there's a little spelling error at the top.
Oh, I see it.
It says complete the following chart using a flow chart or 2 column. I spelled chart wrong and it didn't fix it, so whatever. So I am strongly going to recommend the flow chart to you because then you know you need 3 things stacked, all leading to what you're concluding. But you do as you need to do. Okay? So first let's figure out what we've got because this picture's not labeled for us. So we have to label what we're given before we can do anything else. Okay. So we know that X, where did I get X from? WY, which is this side here. WY is congruent to XZ, so I'm going to label that. But make sure you're realizing it's the whole side length, not part of it. So it's that whole side and this whole side.
So those are both right angles.
Okay? Then it tells us that WZ is perpendicular to ZY. So we've got a right angle here. And we were told that XY, which is this side over here, is perpendicular to that same bottom side. See if you and your table can come up with this proof. Whether you use a 2-column chart or a flow chart is up to you. But see if you can figure out how to prove these are congruent and what triangle congruence theorem we're using.
That makes so much more sense.
Alright, so here's what I did. I took the 2 sides that were perpendicular and I just put them out front. Because that's not actually giving me any information about the sides or the angles. From that, we can conclude that we have right angles, right? But just knowing they're perpendicular didn't already tell me anything about a side or an angle. Okay?
It's not.
It's not paused. I haven't clicked it. So, I put it in the same box because for me that just made more sense in my brain. Like both of these are right triangles because it's a 90-degree in both corners. So that's why I put them in the same. You could have put it as 2 separate boxes and said this is a right triangle and this is a right triangle. Or you could have said this is a right angle and this is a right angle. I don't care.
This makes me want to.
Then I used my given because I always try to use what I'm given first. It just feels easiest. And then I used about the sides being reflexive for this one. So right now I've got angle, side, side. Is that one of them?
No.
Is angle, side, side one of ours?
No. Break time.
No. So then you have to check, can we use hypotenuse leg here?
Yes.
Yes, because they're right triangles. If they were not right triangles, then it does not work.
Was it another leg?
Well, we have a leg. This was my right angle. This is my hypotenuse. And then this was the leg.
I'm not scared.
Okay.
Right? So that was my hypotenuse leg. You have to remember for hypotenuse leg that hypotenuse is the one opposite your right angle. That has to be the longest side. It can't just be 2 legs. That's different. That would be side angle side.
I understand.
All right. So make sure you have some version of this, whether you use the flow chart or you use a 2-column proof. I don't care. I just think that 2 columns are harder because you don't know what you can conclude from your last idea based on your previous entry.
I never know, like when we have to do the examples, I never know like where to put it in the box.
If I sag, center.
Yeah.
All right. So that is it for our notes. We're not going to do 4.